So we're gonna basically convert an aldehyde into an acetal. An acetal is basically a carbon with like two alkoxy groups, or R. I think it's OR. Whatever. Okay, so uh, we're gonna have butane now as our thing, and so we have an excess of methanol. We have an excess of methanol, and so that's going to be our nucleophile. But right now, methanol is a neutral nucleophile. So first, we're going to need to activate this carbonyl so that it can attack it. So, okay, so the first step, we're going to make protonated alcohol, protonated methanol or alcohol. I don't know. So just add an extra H. It's gonna react with H2SO4, and yep. Okay, so now, um, our we're gonna do acid base right here, and we're gonna activate the we're gonna increase oxygen's withdrawing electron withdrawing ability. Um, okay, right here. Okay, so now we formed a delocalized charge, so we could just show the resonance for it. So push electrons, just push that double bond onto the oxygen, and now we'll have this. We're only gonna get two resonance structures, thankfully. Okay, so now we have our now we you see this carbon right here. It's super reactive, it's unstable, and it's unhappy. And so in normal situations, our methanol is not gonna be a nucleophile. It's a neutral nucleophile, so it has no reason to attack. But this thing is so reactive that it's going to attack it. And so just draw your methanol, and it's gonna attack the carb. It's gonna attack right there. So right here. And so this reaction is it's gonna go forwards and backwards, so it's driven by Le Chatelier's principle. And so if we have an excess of the reactant, the system is gonna drive the reaction forward, and the system is gonna respond by consuming the excess reactant. And so in the end, in the product side, we're gonna be forming water, and so we're gonna be removing the water by like distillation or anything. It's probably gonna be by distillation. And so, when we remove the water, the system's gonna respond by replenishing what's lost. So, if you ever have a question about the Chatelier's principle, just say whatever I just said. Okay. Yeah. So right here we have, we're gonna form protonated. I think it's protonated. It's gonna be like an oxonium ion. I think this is an oxonium ion, or I don't know. Honestly, it's just gonna have an extra. It's gonna have an extra like H on it, right? So is that correct? No, should be okay. Good. Okay, so what's gonna deprotonate it? Whatever is in excess, right? So we have an excess of methanol. Methanol is gonna deprotonate it. That is not. Is that methanol? Yeah, that's methanol. Wait, let me just write it correctly. So methanol is gonna deprotonate it. It's obvious, right? Who's gonna deprotonate it? The thing that we have a lot of. So just take that H, push down to the bottom. Okay. So now we formed our first acetal. We call this a hemiacetal. The first three steps is hemiacetal. The last four steps we're gonna make full acetal. In simple words, the first three steps are gonna have one of that old thing, and the last four steps we're gonna have two of that. We're just gonna add the second one. Okay, so now yes, let me just like step one, two, three. Let me just redraw that again. Um, yeah, this is the correct drawing. Let me see where I messed up. Right here and right here. And we have our acetal. Okay, good. So now we're gonna want to make this into an acetal. And so, yeah. What do we have? We're gonna use a protonated methanol. So protonated methanol, because we're gonna want to kick this guy out. If we do SN2, we're gonna end up forming a negative. Like if we do SN2 an attack, this is gonna be like negative. So we need to make this protonated first, so then it can leave. So then it can leave like chill. Okay. So how do you make a protonated methanol? Just add an extra H. And is that that's the correct drawing, right? That should be good. So this attacks right here. Okay. And now it's a good leaving group. Now I don't know, I'm really bad with names, but I think this is it's probably like a methoxide. I don't even know. This thing is now a good leaving group, so now it can leave on its own, and without getting a charge. So and so let's kick this guy out. Um, Unimolecular loss, I'm pretty sure. So okay, he leaves, and so now we're gonna form primary. We're gonna form a carbocation, and so you can show the resonance structures. Let me see if I messed up anywhere. No, this is good. You could show the resonance structures, but we already got the resonance structure we wanted, right? Like this is clearly the minor. The carbon doesn't have its octet, so just attack it again. You know what do we have in excess of? The nucleophile. The neutral nucleophile is not gonna attack the carbon, and carbon's attractive again. It's super reactive. So just draw that. Um, Bro, I'd be playing with the colors too much, but yeah, it's gonna attack here, and yeah, we're almost done. Really, just it's the same thing. And now we have this pronated. What's gonna depronate it? The thing we have an excess of, which is the freaking methanol. So just draw methanol again, and methanol is gonna come and take that, and let's push it back onto here. And so now we're gonna form our. Now we're gonna form. I'm gonna write it right here. We're gonna form our final answer, which is our hemiacetal. And then just draw just draw the acid catalyst, the regenerate acid catalyst, which is just protonated methanol. And I mean, we formed water right here, right? So you can draw water. You can end up we formed water right here, so you can yeah, you can show the water being formed. Okay, that's really it. Yeah, that's it. Man, I'm trying to solve.